This is TWIS, This Week in Science, episode number 558, recorded on Wednesday, March 16th, 2016. People in space. Hey everyone, I am Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with pandas doing it wrong, junior high-level comprehension, and humans in space. But first...
Disclaimer, disclaimer, disclaimer. The following hour of programming has been tested on humans. By listening, you are agreeing to participate in an experiment on intellectual stimuli. While all the content has been tested scientifically, a friend of the show whose wife is a lawyer has convinced us that by disclaiming at the intro and alerting you the general potential for increased intellectual stimuli to be habit-forming, no liability can befall us. Of course, we already secretly know this to be true, which is why we are here once again on This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to Kiki and Blair. And Liz, we have a guest.
We do.
Hello, hello.
Good evening to everyone out there. Welcome to This Week in Science. Once again, we are here to bring you all sorts of science, discussion, fun things. And Liz Warren, who is an amazing physiologist, scientist, has worked with NASA and astronauts on the International Space Station. She makes astronauts be human guinea pigs in space. It's pretty awesome as far as jobs go.
It's true. It's pretty awesome.
And, very incredible note, we both did our undergraduate and graduate work at UC Davis. So shout outs to UC Davis, our alma mater.
Go Aggies!
That's right, go Ags. All right, on this week's show, I've got a bunch of science news. Stories about protein puzzles. I've got epigenetics of obesity. And we're going to talk with Liz about people in space and what happens to them. It'll be pretty cool. All right, Justin, what do you have?
I have some non-political presidential jib-jab and thar be monsters, but not anymore.
There were monsters.
There were be monsters there, but not now.
And Blair, what is in the animal corner today?
Oh, I have two different types of animals that are a little bit lost when it comes to the science of love. And then I also have spiders and video games.
All three could be considered scary to some people, I guess. I don't know. Love, spiders, video games. How do you put those together in a category? Ah! All right, let's get this show off onto some good footing. How about a cool story that just came out of the Centre National de la Recherche Scientifique. It's a French research agency, but they have been working on, they're part of a team working on the Hess Observatory in Namibia, and the Hess Observatory has been focused on looking at Cherenkov radiation in our atmosphere that is produced by gamma rays. So high energy particles, cosmic rays, get blasted from big events like supernova and other things out in space, right? Big high-powered particles, and we can't really tell where they're coming from until they run into stuff, but then they lose a little bit of energy and they turn into gamma rays. And then the gamma rays come and they hit our atmosphere and they set off little sparkles. And the little sparkles in the atmosphere we can detect, and it's Cherenkov radiation. Now that Cherenkov radiation, we can track it back. And through math, physics, we can use these tools in our toolbox to track the paths of the particles back to their source. And so we have been recording really high energy particles for a long time. And a lot of them we have tracked to very specific sources, like very specific supernova. But there have been, for the last decade, as this high-energy stereoscopic system, the HESS Observatory, has been looking at for the last decade, they have tracked energy levels up to a peta-electron volt in strength. So we're talking about cosmic rays. We know they have about 100 tera-electron volts, but it's been hypothesized that we could find that there are basically giant cosmic ray generators in space somewhere that are so powerful that they can create cosmic rays with energies up to 1 peta-electron volt. That's like 15 times the level that we've been detecting, right? And so they've been looking for the last 10 years, and they have found these massively powerful cosmic rays. And because they've been looking at it, they were able to track these back. And they're like, okay, what in the universe, or what in our solar system, what in our galaxy, where would these things be coming from? They tracked it back to the supermassive black hole at the center of our galaxy.
Oh, wow.
Yes, Sagittarius A, the supermassive black hole at the center of our galaxy, has been sucking up dust and other particles into the black hole, and as it does that, it's so big and so powerful that it shoots out these cosmic rays at this massive, massive strength. And they think this is pretty much where their money is, that the data is showing them this. So it's a very exciting thing to think that we have this incredibly active black hole at the center of our galaxy, still active. And they believe that it may have been even more active historically because the energies that they're measuring cosmic ray, tracking them back, the energies that they're measuring these cosmic rays at now and the number of cosmic rays that they're finding doesn't track to kind of what they're seeing coming from the black hole at the moment. So they actually think the black hole was more active previously in its history, and that explains the number of particles number of gamma rays hitting our atmosphere at this moment in time. So historically, super powerful black hole was even more powerful. And I love this. All through little sparkles in our atmosphere.
You can actually see them on a clear night. They just kind of show up right along the. No.
No. You need to have a pretty good detector, and the HESS detector is that, which is very cool. Let's see. So another story that I thought was really neat. We're moving on from outer space into the brain because space is big, so is the brain. Brain's massive in a completely different way. So researchers have been trying to figure out how proteins work. We've got these proteins, and they fold up into these really interesting conformations, and there are all sorts of, there's the chemistry of how and why they fold into these specific conformations. If you unfold a protein from its little proteinaceous knot, let it unfold, denature, you end up with a string of amino acids. And the string of amino acids, sometimes you have little bits that on the string, they're very far apart, but in the folded form, they're right next to each other. And so they can actually influence each other and other stuff around them. They influence the folding of the protein. And then there are other ones that don't fold. They don't exactly sit next to each other, but it's kind of like a string of effects. And so one affects another, affects another, affects another. And so it's this downstream effect of influences. And and we're busy trying to figure out how these very direct influences occur, and then also how these kind of long-term, distant effects occur from the string of amino acids to that folded conformation. So now we've got mathematical models, we've got computers, we've got biochemists who are actually taking proteins and amino acids and changing one, making one mutation at a time to the nucleotides to see how it affects the folding. And so now, this really interesting research at Baylor College of Medicine, they've used a mathematical tool called ETMIP, or no, ETMIP, yes. And it's based on the principles of evolution, and it finds, its goal is to find these pairs of amino acids that are connected to each other by a chain of events. And so, using this mathematical model, they were able to make predictions about which amino acids in the long chain were influencing each other, and then using biochemistry tools, experimentally go in and make the changes based on the predictions to find out what happened in the evolution of the dopamine 2 receptor. So how, during evolution, did the structure of this dopamine receptor change so that its function would change slightly? How did it change step by step by step by step? And so now we're using, I just think it's amazing that we're using this mathematical tool to make these predictions about how the structure would change, and then using biochemical analysis to actually get into it in the lab and figure it out step by step. So this is a very significant discovery. Being able to look into this now will help us really look into how mutational changes in receptors like the dopamine 2 receptor may have influences on psychiatric conditions, Parkinson's disease, schizophrenia, depression, all of these things that dopamine is related to. So the big step is how it all ties together. Yeah. Yeah, fun stuff, right?
Yeah, so there was that game, that Fold It, which I played for a while until I realized I don't know what I'm doing. But it has, every time I think of a protein now, after having played that, I do think of it completely differently. It is, it's like a tangle of yarn, but a very specific, not the yarn is bad, but it's very specifically with the hydrophilic, hydrophobic, and each one of these these foldings as a protein does is unique and is going to have different characteristics. So yeah, being able to get to the point where they can sort of back engineer how it got from one form to another, fantastic. That's huge.
Yeah, it's as if you took your yarn and you tangled it up, and then you go, okay, here's a sweater. But then you untangle it, you tangle it back up, and you go, oh, I made you a hat. It's just going like that. You've got all these different results, right?
Yeah, yeah. That's fantastic. So even though we live in a world with increasing knowledge like this, there is, unseen by most, a world that persists to this day that is filled with unknown creatures. Monsters, even. One such monster has been lurking in the Illinois waters for the past 307 million years and has been avoiding scientific identification since its initial encounter with humans. The Tully monster, named after amateur fossil collecting finder Francis Tully, who found the fossilized freak show specimen in 1958 and has been haunting paleontological-minded mystery solvers ever since.
Haunting, yes, haunting.
So this isn't a cryptozoology Loch Ness monster situation.
It is, except this one has fossils.
Right, so it's real.
Yeah. Just like that, except there's fossils. In fact, now they've found thousands. There's thousands of these fossils of this creature, all from the same Mason Creek region just south of Chicago, which once was the swampy shoreline bordering a big inland tropical sea of the Midwest, and is now a great place to find fossils. What has puzzled the paleo peeps about this creature is its strange structures. It has eyes, though they are at the end of short stalks, kind of like if you would imagine somebody... Like a slug, yeah, like a very cartoony-looking slug with the things and then the eyes at the end, right? It has a long, skinny snout that ends in a toothy-looking claw or maybe mouth.
Okay.
Maybe mouth.
Maybe mouth.
That's a new scientific term.
Could be a
It's
claw,
a maybe
could be a
mouth.
mouth.
We don't
Its
just
body,
loaded it.
from the fossil record, it's kind of hard to tell sometimes. The body's tube-shaped. It's up to a foot long without much else. That's
No
no
appendages?
fins, no appendages. It's the tube. Might even have holes in the side of the tube. It's very weird. Not a lot to go on. Plenty to hypothesize about. They were characterized as soft-body invertebrates, with theories ranging from worms to shellless snails. But the creature remained a mystery until Field Museum scientists, along with colleagues at Yale, Argonne National Laboratory, and the American Museum of Natural History, finally figured out what it is. Digitization of the Field Museum's collection and X-ray analysis at Argonne National Laboratory helped paleontologists take a closer look at the fossils to determine what they were. And if you were like me and enjoy a good mystery creature and want to preserve this one, cover your ears for a moment. The Tully monster is a fish.
A fish.
Yeah.
It's
little
so
more
interesting.
specifically.
I would think it looks more squid-like.
It looks very squid-like. Yeah,
Kind
it's
of like
odd.
a cuttlefish or something.
Yeah. They're saying no. It is more specifically a jawless fish, similar to today's lampreys. Paul Mayer, Field Museum's fossil invertebrates collection manager, which I guess he has to turn this over now because it's no longer an invertebrate. He says the monsters are related to the jawless fishes that are still around today by a unique combination of traits, including primitive gills, rows of teeth, and traces of a notochord, flexible rod-like structure along the back
Notochord, yeah.
that is present in chordate animals, including vertebrates like us. The Tully monster is a wonderful fossil that captures the imagination of every school kid, adds Mayer. When I talk to school groups, I used to use the Tully monster as an example of a mystery that paleontologists have been trying to solve ever since it was discovered. Now I'll have to change my talk and use it as an example that highlights the importance of how amateur paleontologists and researchers from different backgrounds can work together using new technologies and museum collections to solve a mystery.
Wow.
But the Tully monster no more.
Wow, and these things were a foot long. I was looking at it and I was thinking, oh, okay,
Not-
so it was this small thing.
Yeah,
It's not something you want to run across when you're just
it's
out
pretty big.
prancing through the water.
This is fascinating to me. It doesn't look it looks like some weird doodle that you would do in the margin of your history notes or something. Or I would do it. I don't know. I'm projecting now. But it's oh, this is fascinating. There's so many structures on this thing that is just something we've not really seen or explored very much before. I think there's so much still to learn from this thing, and so many mysteries still to solve, especially that hook/mouth and the stalked eyes. Those are crazy.
Right? Those are very interesting signs. And so this is from the overarching number of creatures that have existed on our planet. There's always just this tiny little sliver that we can actually look at in the fossil record because something like this doesn't normally get preserved.
Yeah.
The Mazon Creek region, they have all sorts of examples of insects and invertebrates and all sorts of things that they found in this area. That swamp next to the sea condition was just perfect for capturing things in the mud and fossilizing them. So that's a lucky region we got there, and then Mazon Creek, and I'm glad we finally got this one solved. I love this. I love this creature. Yeah, you're right. It's unlike anything that's living today in its appearance.
Yeah, Liz, did you want to say something?
I'm curious, like, what is its mode of locomotion? The little, like, if it uses its little appendage, mouth-like thing to move, or if it's like a squid or cuttlefish and uses like water propulsion. It's hard to.
Yeah, it's got those like portholes along the side.
What are
makes
those?
it think it could have possibly used that in some way.
Yeah, interesting.
I'm going out.
It has kind of a fin on its very back. From the artist rendering.
From the artist rendering, there does appear to be a little bit of a tail fin. No side fins. Nothing to flap about.
Fascinating.
But maybe that was just for propulsion, and then it's shooting out water in one direction or the other to turn. Like maybe it.
Yeah.
The fin actually probably gives it some kind of stability in the vertical axis, like an airplane tail.
So he's not
Right.
tumbling all the time.
It'd be kind of a spinny type of
Yeah.
motion otherwise.
Wow.
And from crazy monsters to what, Justin? Did you
Oh,
have another story? Or did you
this is
save it
this
for
is
later in that?
no. I got it right here. This is a readability analysis of presidential candidate speeches by researchers at Carnegie Mellon's University Language Technologies Institute. Finds most candidates using words and grammar between a 6th to 8th grade level. A historical review of their word and grammar use suggests all 5 candidates, and they include Rubio, although I guess he's dropped out. Trump, Cruz, Rubio, Clinton, Sanders have been using simpler and simpler language as the campaign has progressed. Some of this can be weighted on how well a candidate is doing. Trump's grammar use spiked. The highest part was in his Iowa caucus concession speech, and his lowest grammar use was during the Nevada caucus victory speech. They hypothesized maybe win is a word more accessible to 3rd graders than regrettably or unfortunately. Comparison to the candidates with previous presidents shows Lincoln outpaces them all when it comes to grammar. He was up in an 11th grade level.
Well, he is known as the great orator, right?
Right, but he taught himself to read.
Yes.
And that should be something that we all aim for, right?
Yeah.
Do that.
This is also the lowest historically, going back at those that they looked at, was George W. Bush. His grammar was 5th grade, although he only barely edged out Trump in low grammar. They went beyond the grammar. They looked at vocabulary. Based on vocabulary, campaign trail speeches by the present and past presidents, Lincoln, Reagan, Clinton, Bush, Obama, they were all around that 8th grade level, all around. But while current candidates ranged from Trump, who has a vocabulary ranging the 7th grade level, to Sanders, who is the highest at the 10th grade for those who are currently wanting to be president. Trump and Hillary Clinton's speeches showed the greatest variation, suggesting that they may work harder than others at tailoring speeches to particular audiences.
Which I would believe. I think that makes sense.
Yeah, but it's sort of, if you're dumbing yourself down in one state versus another, that's sort of, I don't know, maybe that's the right way to do it. They seem to be winning. Trump and, where we go? Of the current cast of president wannabes, Bernie Sanders holds the title of the best vocabulary, then Rubio, who has since quit the race, then Hillary, then Cruz, Trump at the bottom. In grammar, it actually would have gone, or did go, to Rubio, but I think that helps if you memorize the text as written of a speech you're going to get. The more you actually memorize exactly word for word how it was written, perhaps you're going to come across a little better. So grammar gold goes to Rubio, then Hillary, then Cruz, Sanders in a tie, and again Trump at the bottom. What's also interesting in this, this is one of those I would not have guessed. While including past presidents, Reagan would actually be the one to edge out Sanders for top vocabulary. He gets a little bit better than Sanders does in vocabulary, and second only to Lincoln in grammar. So Reagan, great orator. When we think of Bill Clinton, people think this is a person who gave great speeches, but perhaps they were also easily digestible. He is only saved from last place in vocabulary by Trump being on this list.
So I think there's a couple things to keep in mind here. There's, who your audience is, but there's also sometimes you can hide behind big words. So it depends on how plainly you want to speak. Sometimes if you want to speak very plainly about what you want to talk about, you don't need to use big words. And sometimes big words are the perfect escape to talk around something.
Yeah, and coming from the media standpoint, I will say that the television news and radio, radio depends on the channel, but basically the first thing you learn is that to write news for television, you write to a 6th grade level. And the reason you do that is because people are busy. There are a lot of people who maybe are working at more than maybe an 8th grade level or 6th grade level, but the majority of people are watching the news or listening to the news while they're doing something else. Like they're cleaning the house, they're dealing with their kids, they're having a conversation with somebody, they're multitasking in multiple ways, and the news is just kind of there while they're cooking dinner or, whatever it happens to be. So you write to or you speak to a plain, easy to comprehend level, because especially now that that the news cycle is so huge and sound bites rule the day, you have short, easy to understand clips, sentences that can be taken out for any kind of outtake and will get your point across to anybody, no matter how they're listening.
I also do think that though there may be something to the memorization part, because of for one, how well Rubio does in this, and our understanding of Rubio is that he was saying things verbatim multiple times, probably as they were written. You look at Reagan, who was an actor, who probably does follow the text, the lines he's given to speak, right? And then it makes me wonder, because then Clinton might have written a speech, but he might shoot a lot from the hip. We know Trump only does this. So he's talking only in that verbal context. It's not, when you write, you do tend to get more verbose than when you just speak to people. But I keep wondering then, because what we have, of course, of Lincoln and his high grammar is a written speech. What if he ad-libbed? If we had an actual recording of my fourscore and, a while ago, our country was, it was formed and we did some stuff. But now we've moved on, and here's what we got to look at next. What if he ad-libbed his way through the speech and didn't follow it verbatim? Anyway. But yes, we are being talked down to, or perhaps this is just what we get at this level. If anybody who's already been eliminated perhaps used too many big words.
I like big words. I think big words are fantastic. Like abracadabra. No.
You know what? Actually,
what's great?
You know what some of my favorite words are, though? Oh, go ahead.
I was going to say one of the best words is science. It's not a big word.
Science is a good word. One of my favorite phrases, though, of all time, is Blair's Animal Corner.
Which we are going to get to after the break.
After the break. Oh.
After the break. Right now, we are going to have our interview with Liz Warren, who is a scientist. She's a physiologist, professor, and she's worked in the science communications with the International Space Station as well. She has a passion for human space flight, and her Twitter handle is Space Monkey. So that gives you an idea of her love for space and all things space related. She has done research in neuroscience, systemic physiology, cancer, and molecular biology, and has worked on space flight operations in NASA's mission control for human research program experiments on the Space Shuttle and International Space Station.
Yes, it's true.
That's pretty amazing. I'm blown away by everything that you have been up to since we both finished grad school.
It's been such a blast. It's so much fun, and like you said, I am passionate for this stuff. I can't get enough, and so I try to involve myself in as much as possible. And there's a lot going on at NASA, so it's an exciting place to work, and it's an exciting place to be.
Yeah, I can see behind you. You have there's space shuttle models on the shelves behind you.
Oh yes, how could I not? Yep, got some other random stuff back there.
Yeah, and Yoda. I was gonna say
Yoda, because Yoda's pretty awesome. I love Star Wars too. So.
Yoda also not known for his grammar.
There might be something there. Yes.
Great speaker, but not known for his.
Not a very high grade level there, I'm sure of it. All right. So recently, astronaut Scott Kelly, came back from the International Space Station, and he spent 340 days, almost a full year, on the International Space Station. Liz, I'm really curious. I mean, we found out over the last couple of weeks he is going to retire from NASA, but he is going to continue as part of the research program with that human guinea pig aspect, finding out what has happened to his body, letting researchers understand more about what long stints in space do to the human body. But what do we know for sure? I mean, a lot of the data is yet to come back about the long-term changes, but what do we know for sure about what happens to people in space?
So we've been sending people to space for over 50 years now, and our duration of spaceflight has increased. We knew from the beginning that, or we had an inkling from the beginnings that, well, when you go to space and there's a lack of gravity, what kind of changes will happen in the human body? Before, Alan Shepard and John Glenn and our Mercury astronauts went to space, there were doctors and scientists on the ground who were worried about, well, will they be able to swallow? Can we eat in space? Will their eyeball to read the instrument panel? These were all concerns that we had long ago, and as we learn, as we stay in space and learn more, we still don't know an awful lot of things. But we have learned that when you go to space, a number of changes happen in your body. It looks like a blast to float around in microgravity, right? We'd all go, right?
Yes.
But microgravity and the spaceflight environment is not all that good for the human body. It's kind of rough on the human body. So long duration spaceflight. We've been staying on the International Space Station. We've been sending people to the International Space Station for over 15 years now. And it's been continuously crewed with international partners. So we have European astronauts, Japanese astronauts, Canadian astronauts, and Russian astronauts, and American astronauts. And most of the time, we stay for about 6 months on the space station. And during that time, we know that astronauts will lose some bone mass. Bone is only as strong as the forces that are imparted on it. It's like calculus. If you don't use it, you lose it. Very much true for bone.
Have you seen the new TV show, The Expanse, on Sci-Fi?
I've heard about it, but I have not seen it yet. I got to check it out, I know.
Okay, the reason I ask is that they, Ed from Connecticut here in the chat room brought it up in the chat room, but they have some, they really show the difference between people in different amounts of gravity and their body differences, and they have they have the belters who come from, say, Ceres out in the asteroid belt, and they basically have very, very little gravity, and so they're very tall and lanky and don't have strong bones. And so I'm just, just the science of it, I think, is really interesting. The fact that they can't go back to Earth without it being torture.
That's interesting. I will definitely have to check that out. And it's so true. We wonder these questions. What will people look like if they aren't born on Earth and are born elsewhere, born in space, and multiple generations, what will happen? But anyway, so bone, we lose bone density, bone strength. Our cardiovascular systems get weaker in space. The heart does not have to work very hard to circulate blood and to fight against a hydrostatic column. Our immune system experiences some dysregulation. Our muscles atrophy. So all of these changes start to happen pretty quickly upon entry into the microgravity and the spaceflight environment. We also talked about radiation today. The radiation environment in space above our atmosphere, our astronauts get a lot more radiation than we do here on Earth. And so the longer you stay in space, the worse the effects.
Absolutely. I mean, we know even just from taking a cross-country flight that takes you up to 30,000 feet, you get, a dose of radiation. But how much radiation will Scott Kelly have gotten, or anyone who spends that extended period of time?
So I think the numbers kind of vary because it depends a little bit on space weather. It depends on the activity of the sun. It depends on the activity of how many galactic cosmic rays come in. But I think a very round number is to say that for every day that an astronaut's in space, they're getting at least 20 times the radiation that you and I are getting here on Earth. And we do. There's radiation bombarding us all the time. Our atmosphere does a really nice job of helping to protect us, but there's radiation all around us. Even our computer monitors are giving us a little bit of radiation right now.
Right.
So it's an accepted risk going to space, and astronauts are happy to do it. So the longer you stay in space, the more cumulative these effects are. There's a lot of people at NASA that work very hard to try and keep astronauts healthy and highly functional while they're in space, because we want them to work, we want them to be healthy, we want them to get home to their families and be healthy. And so we devise countermeasures. Countermeasures are devices to mitigate or prevent the negative changes of being in space. So what's the countermeasure for losing bone and muscle and cardiovascular fitness? Exercise and nutrition. So those are really big countermeasures for us. We didn't talk about psychological health. Living in space in a can for 6 months or for a year, like Scott and Michaela just did, are there some psychological effects of being separated from your family, from your loved ones for a year? We're asking these questions now. The one-year mission, one of its prime focuses was understanding what about a year in space will do to the human body. And we did a lot of science collections on both Mikhail Kornienko and Scott Kelly. There were 2 crew members, a Russian and an American, that stayed in space for, like you said, about 340 days. A mission to Mars is probably going to be closer to 30 months, not just 12 months. So we're kind of taking these incremental steps. This is a pretty big step, and I'm so happy that NASA understood the risks, or try to understand the risk, and then take a next step. And that's what we do at NASA. We're always trying to push the boundaries. So you mentioned that, yes, Scott is retiring from NASA, but he's going to continue to participate in the science program. So that one-year mission, I like to say it was really more like a 3-year mission. We were collecting data, and we do this for all crew members, all astronauts. We collect data on their bodies as a baseline before they go to space. We do a lot of data collection while they're in space, and we're going to do a lot afterwards, because we're very interested in not just the changes that happened to Scott while he was in space, but the recovery. How long does it take him, if he lost bone mass, which I don't know, if he lost bone mineral density, how long will it take him to regain it? Will he regain it? What about his cardiovascular system, muscle? All of these things that we know are changing, we want to measure his recovery.
And
so
he has
like 3 years.
He has a twin, right?
Yeah, I was going to bring that up. Yes.
So there's this other sort of control group that didn't ever leave the
on
planet.
Earth.
Yeah.
Right? So this is like a little too perfect. But he came back. He was a little taller than his twin.
Right. So when you go to microgravity, all astronauts tend to grow a little bit. I think Scott said he grew about 1.5 inches, but I don't know if he measured that absolutely. But you know what? We all
1.5
grow.
inches is huge.
That is crazy, I know. But you know what? Tomorrow morning, you're going to be taller than you are right now, too.
Yeah,
Maybe it's
that's
probably not
right.
1.5 inches, but just a little bit. It's just removing that gravitational loading on your spine.
And that's why we have the tiny grandmothers.
It is, gravity. Not cool.
And the other thing I'd be I guess of all the things in microgravity, bone loss, I feel like you'll get to Mars and drink a lot of milk. I don't know what Martian milk tastes like, but hopefully it's good. But isn't there's a significant amount of ocular degeneration that takes place?
So, Justin, as I said, we're continually learning, and in fact, just in the last couple of years, we started, noticing a trend of reports of astronauts reporting changes in their vision, and all of it getting more impaired, a little bit of farsightedness going on, and we started looking into this further and realizing that we have a new risk in NASA speak. This is something that has been identified that makes us scratch our heads and get concerned, because we don't want our astronauts to be losing their vision, and especially if this is happening on a 6-month mission, we're always looking toward Mars. With an eye toward Mars, we know what's going to happen over a longer mission.
You'll have to supply lots of prescription glasses just because it's hard to, get a pair up there once.
Yeah, I was going there in my brain thinking about an astronaut trying to put in a contact lens is what I was trying to imagine.
So it's been done. Certainly, astronauts have worn contact lenses. So these changes in vision, there's kind of two schools of thought. We don't fully understand this problem, which makes it scary to us. We like to fully characterize and understand a problem. We don't fully understand this yet. And so we're spending a lot of time studying it, characterizing what is going on. So we have all kinds of eye tests that we're doing on orbit. We're doing we're looking at the shape of the eyeball itself. We're using an ultrasound. We're using OCT. It's optical computed tomography. Sorry, I had a little bit of a brain freeze there. Where we're taking very detailed pictures of the back of the retina. We're doing simple eye chart tests, all in effort to better understand what is happening. And so there's really two leading theories, but one leading theory is that it's related to the cardiovascular system. When you go to space, actually, if you look at some pictures of astronauts, you'll notice they look a little bit different when they're in space. Their face gets a little bit puffier, and that is because we don't have gravity pulling fluids down into our lower limbs, into our lower body, and that fluid tends to accumulate in the upper body. Our heart and all of our blood vessels are kind of designed to push fluid up. That happens whether you're in gravity or not. So all this fluid kind of gathers.
So instead of it getting evenly spread out, because the heart and the cardiovascular system is bent on getting blood back to the heart and getting it to the brain, then
we have valves in our body, so we get a little bit congested, and that may be resulting in increased intracranial pressure.
Interocular pressure, then,
which results or finds its way out toward the optic nerve, pushes against the back of the eyeball. We've actually seen some astronauts have some globe flattening in their eyes, and that's of course going to give you a change in your vision, right? Because now the light in your eye is coming to a focus elsewhere in your retina.
Yeah, I remember a study years back that looked at tie wearing in men, and it found a correlative link in, I think, macular degeneration with individuals who wore ties and those who did not. So it would be the same kind of thing, where the tie is increasing pressure.
Yeah, you're impeding the fluid drainage from the brain, from the cranium. So So these are all types of things that we're looking at very carefully. Some other really interesting tests that were done on the one-year mission were we call them functional tests. And those functional tests try and tie a measurement like, okay, we want to know exactly how much strength Scott has in his thighs, in his legs, in his gastrocnemius, all these different muscles. But then what does it mean functionally? So one of the very first tests that the astronauts did when they got back to Earth was actually in a medical tent, constructed right outside their space capsule. It was called field test because it was done in the field. And we asked them to stand for 3 minutes, get up from a prone position, get up from a chair. And these are like, the corollary is, hey, when we land on Mars, are you going to be able to get out of your seat? Are you going to be able to be functional? When we got them back to Houston, well, Scott Kelly actually came back to Houston. Mikhail went to Moscow. But we continued these tests and got a little more detailed with them. Can you open a hatch? Can you open a door? Can you climb a ladder? Functional tests that really tell us capability-wise, what are the astronauts' capabilities after spending 6 months or after spending a year in space? So there's a number of studies that we're doing on our crew members and our astronauts in order to understand what is happening. So this is, talk about really cool stuff. It's really exciting. It's really
starting
exciting.
to really push the limits of our knowledge.
Absolutely. It is, we need to. We need to push the limits of our knowledge. We have a lot of data at 6 months with all of our, we have dozens of astronauts who have stayed on the space station for 6 months, but now we need to start looking a little bit longer. And what's next? We're not absolutely sure. We're still figuring out our plans, whether we're going to do more one-year missions. I'm pretty sure we will.
2-year mission?
Possibly.
Right?
Possibly.
It seems as if you have if there's a 30-month Mars trip out there, a 2-year mission might be
It might be a smart thing to do. I think for the most part we were very prepared for this 1-year mission. So I don't think there's anything that's going to be super surprising in the data. At least ideally there's not going to be anything that shocks us in the data. That means maybe we weren't so prepared to do this in the first place. So I think we're going to see trends that we were expecting. But of course, you can't. You have to do the experiment, whether
right. That's
the hypothesis. That's just our hypothesis. So
and a lot of times, I always joke that it's always fun to find something you really weren't expecting from your hypothesis. But in this case, actually, if everything does sort of fall into the realm of what was expected, that means we've got a good grasp on it and can maybe come up with ways to sort of preserve that body, that eyesight, and that blood flow. Find a way to put somebody into a tube that compresses them downward as they sleep. I don't know how this would work, but sort of some sort of compression sock you wear on your head, perhaps.
So, what we actually got?
Everybody's going to look like they're ready to rob a bank. Not like stockings over their heads in space.
So here's something that we actually do have. We do have a countermeasure to try and prevent this. We have a couple of countermeasures to try and prevent the cephalid or the headward fluid shift, and we're kind of testing them out. One of them, you'll like this, is a pair of pants that suck.
Yes.
They're actually rubber pants that we essentially hook up to a vacuum and create lower body negative pressure. And by doing that, it actually pulls fluids down into the lower body. And the Russians have been using this for years, and we're just starting to try it. And we did it in conjunction with eye tests. So we'd have the ultrasound on the eyeball, turn on the vacuum, and see, well, are we able to detect any changes in the eyeball shape or all these other eye tests during lower body negative pressure. So we're trying out all of these things.
It's also fantastic because it takes that whole sort of vision of the future, like with people in sleek spacesuits, and puts them in these giant rubber inflated pants.
Pretty cool. So you mentioned Scott Kelly's brother Mark.
Yes.
A twin. What are the odds of having twin astronauts? They're phenomenal. So we have twin astronauts. And so Mark was a little bit of a control for us. It was a whole separate set of studies called the twin studies. And a lot of those studies were looking at kind of genetic markers that may change in microgravity, the microbiome. It wasn't a super controlled study, but we planned it that way. Scott and Mark did not eat the same, exercise the same. Mark was more like what we would call free living. While Scott was in
free range human.
Free range astronaut. And he participated in a lot of the same science, blood draws, urine collections, saliva collections, microbial swabs, other bodily fluid swabs. And so one of the interesting studies was looking at telomere length. And so telomeres, are the caps of our chromosomes. And as we age, telomere length decreases. Stress, a very stressful environment, decreases the hypothesis. The expectation is that Scott, his telomeres are going to be a little more burned down than Mark's will, because he has been living in an extremely stressful, physiologically and psychologically and environment.
But does relativity get in the way of this? I mean, he is, how much further above the Earth?
It's a valid question, right? So, the theory of relativity or of special relativity says that the faster you travel, and I think the further you are from a gravitational source, I think, the less you will age. And so, indeed,
I tried to use that in defense of a speeding ticket once. It didn't work.
No, that's not going to work for you. But indeed, I think if the calculation, I think Neil deGrasse Tyson did this calculation actually, and it's, I don't remember, it's like 1/100th of a second less, or maybe it's a little less, a little more than that, but it's negligible how much less Scott technically aged than us here on the Earth during his year in space, but it's it's not much.
Probably not enough to influence the telomeres as much as the radiation and just the low G environment and everything he was experiencing.
Yeah.
But what about the reduced exposure to pathogens from out there?
Right.
And also there's less physical stress on parts of your body as well.
So this is why Blair's interested in going to space. She thinks if she gets up there, she'll be in a bacteria-free environment.
No,
not necessarily. Not necessarily. You can
it will
open
not
up
be a clean space.
You can open up that medicine cabinet, Blair, and all the germs will be floating there in a globule of water that comes out to get.
Yes. But I'm saying that there's many factors to being out there, and there could also be some positives as well as some negatives in terms of aging.
Oh yeah. Certainly. You just mentioned that the cleanliness of the environment. So the space station is a pretty clean environment in terms of bacteria, and we measure. We do microbial swabs. We're looking not just at the microbiome of the humans on board. We're swabbing the walls of the space station to measure the microbiome of the inside of the vehicle as well. But sure, less exposure to a variety of pathogens.
This has been mankind's quest for longer longevity since the beginning of leaving Africa. We've always been going and trying to find places with less humans, because that's always the safest place to be. It's all those other humans that cause unexpected early termination. So.
That's the whole reason for the drive of humanity to spread. This is what you're saying.
It's just to get away from other people. We're just looking to go someplace where there's not other people who will mess things up for us.
Yeah.
So space, the final chance.
The final frontier.
Yes, and once we get to this, there's plenty of places to go, people. We just got to get this whole technology down, and we'll all be able to escape this planet, seething and teeming with people.
Yeah. On the psychology front for spending long periods of time in space, I mean, there's a human precedent for being on ships for long periods of time with very small company.
Yeah.
Are we looking at old logbooks to see if there's psychological deterioration of crew members from ships from hundreds of years ago? Or
absolutely. So our whole behavioral health or psychological countermeasure team, in fact, I think on one of Scott's earlier missions, he read some of Shackleton's writings and journals in one of his books. It is a fascinating topic, and there's something called the third quarter effect of military deployments, submarine voyages, I'm sure other types of voyages, when you're past halfway, so that's good, but you're only halfway.
and you look and the finish line is so far away.
The finish line is still quite a ways away. So I know our teams on the ground were very aware of that, and I don't think in all of our studies we've seen any astronauts on the space station truly experience this third quarter effect. And the way we expect we would see that is a little bit of a decrement in performance, in mood, in attitude. We've never seen that on the space station that I'm aware of. So
No
that's kind
mutiny.
of an interesting.
No mutiny on the horizon there.
No,
Well,
no.
so here's the other thing, though. I mean, there is something okay, because I get they're away from the families for all this time, but that's physically away. There's communication. I mean, they like basically pick up a phone and have a Skype type conversation with a loved one.
They can. They can almost at any time of day, pretty much, pick up the phone. It's like an IP type of Skype call and call their families. They've got video conferences, but still the question exists. Certainly, a year away, our military folks do this all the time, not regularly, but being off the planet has it's a little bit different. You maybe only are going to be interacting regularly with 5 other people. There's 6 people that live on the space station, and so it may be a little bit different than being deployed somewhere. Simple things that Scott mentioned and a lot of other astronauts have mentioned are the earthly senses that we don't. They don't feel a change in temperature. They don't feel the sun on their face or a cool breeze, rain, the smell of trees, the sound of birds. There's a lot of things missing on the space station that make it a very un-Earth environment.
That's fascinating. That's something I never thought of. What does it smell like on the space station?
I've heard so many different things. I think they get a little bit nose blind, and partially because of that fluid shift. It's almost like having a head cold, many astronauts say, and so they almost feel a little bit congested, which affects their sense of smell.
Right.
Also, sense of smell affects taste, right? So when you are eating a meal, there's an aroma that comes off of the food, and you smell it as you taste it. That happens because that's heat rising off of your food. It doesn't happen in space. There's no buoyancy-driven convection. So the aroma of your warm food doesn't even come up to your nose. So there's almost like sensory deprivation.
Yeah.
Not really, but you can consider
Little bits.
Oh yeah. No, I mean I figured that you would have to then. I mean, of course NASA's already doing this, but the designing of the food can't rely on any of the flavoring coming from the smell, because you've done that test before. We're blindfolded, you smell banana, then take a bite of an apple, and it's totally throwing off the taste of the apple. So they must just be concentrated on how the taste buds will interpret this without scent. That's a fascinating food.
Well, and so much of the food also is in pouches.
Yeah.
So
Yeah, it's not even. Well,
it's not even solid.
It's not getting to your nose.
I have a superficial question. Do we know what Scott's first meal was when he got back to Earth?
So he did say in a press conference that like the first food he ate was a banana.
Really?
The next thing he ate, and I'm going off of what I recall him saying, was a salad, something nice and crispy. They don't get a lot of fresh food up there.
Although we have learned that they can grow lettuce.
We grew lettuce while Scott was on board, and that's pretty cool. And then after that, I don't know what he ate. But imagine eating food from a pouch for a year, and how much you would want to eat not from a pouch.
Something nice and warm, and a great odor to it and taste. Yeah, I bet that first meal was pretty awesome.
I bet. But that leads me to another question. We're doing so much science on the space station. We've just been talking about human research right now, but there's technology development, there's biology and biotechnology, physical science. We do even Earth and space science. We're observing our own Earth, looking out into space, and a lot of educational activities as well. So, I think Scott, while he was on board for that year, there was at least 400, maybe 450 other experiments going on that he maybe took part in, maybe as simple as flipped a switch for, or maybe it was going on outside the space station, and he had no interaction with it. But there's a lot of science going on aboard the space station. Some of it is meant to get us further into the journey to Mars. A lot of it is meant to benefit life here on Earth.
And then, of course, there are the things that you don't really know how they're going to affect us on Earth, but end up being amazing discoveries that do. So, like, for instance, the research we were talking about, the physiology related to the intraocular pressure, this could lead to discoveries, technology, medical advances that will help people here who suffer from macular degeneration.
Right. Actually, or traumatic brain injury.
Or traumatic, yeah, exactly.
Actually, a lot of the research, thanks for bringing that up, a lot of the research that we do on astronauts is similar, or the processes that they go through are sort of similar to aging. So osteoporosis, they lose bone, I mentioned. That's very similar to disuse osteoporosis of, I think it's 70 million Americans 70 million Americans have osteoporosis. If we can figure out the real mechanism of what's going on in osteoporosis and how to prevent it in astronauts, maybe that is applicable to our elderly population and cardiovascular disease as well. So a lot of what we learn to keep astronauts healthy is applicable to all of us. So that's a good thing.
And in terms of the other discoveries related to this microgravity, do you think that the findings on the International Space Station are going to have knock-on effects for, say, suborbital space flight, where people are just going to be going up for a short period of time and then heading back down, but maybe doing it quite often?
Very possibly. So, transiently, the first effect that I think most space tourists or suborbital flight participants will experience is some neurovestibular disorientation. Fortunately, I don't think bone loss or muscle atrophy will be a problem for people that are taking these suborbital flights, but certainly things that we're learning on the space station will, I hope, help people. I hope to be one of those people. I hope one day to be able to buy a ticket and take myself a suborbital ride or an orbital ride myself.
Have you been on the Vomit Comet?
Oh yes, I've flown on the Vomit Comet a lot. I think actually the picture in my over here in my little profile pic is
that's right.
And it is, oh my gosh, it's the best thing. If you have never done this, there are commercial companies like the Zero G Corporation where you can buy yourself a ride and take it. It's like the best, most weirdest feeling in the world to be that free, to be floating. Have you seen the OK Go video?
Yes, the OK Go video is amazing.
Yes. Inside Out is their latest video, and oh my gosh.
I thought about I thought about the production on what would have been involved in the making of the video. So they have moments because these Zero G flights or whatever company, they do parabolic flight, right? So they go up and they go down and they go up again and they go down. And when they're going down, you're quote unquote weightless and floating inside of the cabin. But then when they're going back up, you experience G because they're going back up again at a significant speed. So you go back and forth between these two states. Yeah. And I think if you watch the whole OK Go video, they do their shoots in a single take. So they had to go back and forth. They had to stop and then speed up the camera for the high G portions and then
start again.
Yeah.
Oh my gosh.
Pretty wild. That was quite a production to pull off.
How did it feel for you in your vestibular system going between the no G and more G?
So it's pretty provocative. Of course, there's medications that people can take that prevent nausea, but I've been unlucky enough to experience some nausea on those flights and had to use one of the NASA emesis bags.
Oh no.
Yeah, it's all right. You know, I would do it again tomorrow, no problem. And even if I knew I was going to hurl, but it is fairly provocative because you're transitioning between zero gravity and it's about 2G, twice Earth's gravity during the pull-out portions, and so it can be a little rough on the inner ear. But hopefully, you know, I think a lot of people at these commercial companies are looking really carefully at that because they want their customers to have a good time on their flights. And so I think there's a lot of effort to make sure that there's medications and care for customers, and you know, the goal is not to hurl, I think.
Right. If you hurl in 0 G's, you're gonna have a bad time.
If you're gonna spew in here.
Could be the only industry in which you hear the terms prophylactic emesis.
So we need to get our Patreon dues like way up there, and then the three of us are going up.
That's right. Yeah. We'll go for it. Oh, this is just fantastic.
You should record a TWIS in 0G.
Yes. Oh my God, that would be fantastic.
You gotta do it.
And now we're weightless. Okay. Talk about science. There wouldn't be much talking about science. I'm sure there would just be like
lots of screaming.
Exactly, lots of screams. Exactly.
I'm down. Let's do it.
Do it.
You're good. Oh my goodness, this has been such a wonderful, it's been a great conversation. Thank you so much for joining us.
Absolutely.
Yeah.
Were there any questions that came in that we need to answer?
I think we got to most of them. I've been watching the chat room
and bringing things up. Yeah.
Yeah.
Yeah. I think I don't know. For some reason, they've started talking about kangaroos.
That did happen.
A kangaroo hopping on the moon.
Yeah. I can't explain where it came from.
I don't know what happened there.
All right.
Oh, good gracious. Yeah, so what's next for you?
What is next for me? You know, so the next big thing that I am excited about happening at NASA is, well, how do we follow up a year in space? That's kind of a big thing, right? So in June, well, actually we have a launch to the space station this Friday. 3 new crew members are going up. But the next crew is what I'm really excited about. An astronaut named Kate Rubins is going to the International Space Station in June, and with 2 crewmates. And Kate Rubins is a scientist's scientist. She is going to do the first DNA sequence in space. She is a cancer biologist, a virologist, a virus hunter. She's done work on Ebola. We're not bringing Ebola to the space station, but Kate is going to do some awesome cell biology for us on the space station. And so that is next for my goal, is to make sure that we get a lot of information out there, and that everyone knows that there's an awesome woman scientist on the space station starting in June. So that's great. That's next on my radar.
I will absolutely help talk that up.
That's
big
awesome.
Time.
Yeah.
Yes.
She went to UC San Diego, so one of our sister schools, and Stanford, and so she's a good one.
Oh, that'll be fantastic. I can't wait to see what she discovers.
Yeah. It's going to be cool.
And if people want to find out more, can they follow your Space Monkey Twitter handle? What would be good social media places to send people?
Yep, you can follow me, but also I do a lot of tweeting on the ISS research. So it's at ISS_research. That's where we get a lot of science news out about what's happening on the space station, results and current happenings and news stories. And on Facebook, ISS, also on Instagram, ISS. So we're trying to put a lot of information out there about what we're doing on the space station. We're doing a lot of good work. Science takes some time, so instantaneous results are not a thing that we're seeing, but there you go.
But that is something that we like to follow. Science is not necessarily instantaneous, but it's the process of discovery that can sometimes give us so much enjoyment.
Oh, absolutely, absolutely. And the discoveries that we sometimes make that we weren't necessarily looking for, that's pretty magical too.
So next up, we need to get somebody up with a 360-degree camera to do a 360-degree virtual tour of the International Space Station. If that
Yes. You know, that may be on tap pretty soon. ESA brought up, the European Space Agency actually brought up something similar. So it's not a video, but you can move around the space station in 360. I don't think it quite works on I may be wrong about that, but stay tuned on that. I think that's coming soon. Yeah,
that would be awesome. Thank you so much for joining us tonight. This has been a lot of fun.
I've appreciated the opportunity to talk with you guys.
Yeah, it's great, and we wish you well, and the astronauts that you are helping to send to space, and the research that is being done. Go science!
Go science! Woo!
All right, everybody. We are going to take a quick break, and we will come back with Blair's Animal Corner. Stay tuned for more This Week in Science.
Explain the things you heard with more than intuition.
Hey everybody, like what you hear, you like what you see? This Week in Science is supported by listeners and viewers just like you. So if you feel like you need a little bit of TWIS in your life, head on over to TWIS.org, TWIS.org. We have a Zazzle store where you can find merchandise with our logo all over it, which could make you feel happy that you are emblazoning yourself with the TWIS logo. It also could be a gift that you give to someone you know or love who enjoys This Week in Science. It also helps other people find out about TWIS. They go, what is TWIS? What is this shirt that you're wearing all the time? And you go, well, let me tell you. So there are many ways that you can help us out. One way is by buying a shirt, a mug, I don't know, the mouse pad, stamps even. Zazzle store, twist.org. Additionally, we enjoy support from listeners through donations, and your donations pay for our hosting, bandwidth, equipment, all sorts of things that we need to keep the show going. $2, $200, whatever you are able to give, every single penny helps us keep this show running like the smooth-oiled machine that it is. Anyway, go to twist.org. We accept donations a couple of different ways. PayPal donation buttons are all over our website, twist.org, so you can support us through PayPal if that is your choosing. Additionally, Patreon is a platform that we use that allows you to support us in an ongoing way that is not PayPal. And it also helps, we give you a little kickback in return for your help. So say if you donate at the $3.14 level, we give you a little round patch, cool twist patch that you can put on your bag, and we'll also send you a sticker, and there's all sorts of things that come along. The perks of donating. Whatever your preference, head on over to twist.org and listen to the most recent episode. Comment in the comment section. Let us know what you think about the show, and donate, PayPal or Patreon. If you're unable to donate, we absolutely understand, but everyone can help just by sharing their love of TWIS. Tell somebody you know. Post it on Facebook. Put a review on iTunes. There are many ways in which you can help TWIS out just by sharing us with people that you know. We thank you for your support. We really could not do this without you.
I'm a most excellent specimen. The power to live on and on for all days is right at your fingertips if someone pays. Hey, says that his aura will keep you alive for 3 easy installments of $10.95. The device he uses sucks out the bad juices and leaves no bad bruises. It simply deduces the proper percentage of X in your brain. This miracle cure leaves no permanent pain. And still, you can't believe what a skeptic I am. I can't believe you believe in that plan.
And we are back with more This Week in Science. I had another story ready to go here, but actually I thought of a question during the break.
You have a question?
I have a question for Liz. I'm glad she's still here, because this is now a pressing question, which I didn't realize, I didn't even think of. It just occurs to me, if you get sick on the space station for something that you would want to take antibiotics for normally, can you still? Because how would you replenish your gut microbe? Are they adding bacteria to or microbes, microflora to the food the astronauts eat? How would this work?
Ooh, so this is a great question. There is a pretty extensive medical cabinet on the space station because, you know, we want to be prepared for things that may happen. And there's always someone on board who has been trained in some pretty extensive first aid and medical procedures. There's a lot of doctors on the ground as well that the crew can always and will always refer to if someone's not doing well. Antibiotics. I don't know 100% sure that there's antibiotics on board. I assume there are. I know there's at least antibiotic ointments. So if you took a course of antibiotics on the space station, how would you replenish your gut flora?
And I assume nobody's going up there. You've tested everyone, make sure nobody's got the flu before they board. So where are they going to catch it? But if somehow this happened.
So, and this is a question I don't know the answer to. I assume that, so it's not a completely sterile environment, right? And when you take a course of antibiotics, hopefully you're not decimating everything in your gut flora. It'd be a pretty strong antibiotic. So I assume it just, grows. You just normally get it back. They don't have yogurt up there. There's no refrigeration. But I assume that for those of us here on Earth, same thing. Your gut will replenish itself. It might take a little bit longer in microgravity, but I don't know. What do you think?
Maybe NASA should work on the poo pills, fecal transplants.
Right. No, that's kind of where I was going, because I'm like, I would assume you get it from touching, but a lot of your microflora you actually can get from eating fresh fruits and vegetables. I mean, it's not only healthy for them, but that's also where you can pick it up. So, I don't know.
I will have to look that up. I don't know. Talk to somebody.
So,
interesting question. Hasn't come up
Blair seems to have transformed herself somehow.
Yeah.
Into a panda.
Because do you know what day today is?
Is it Panda Day?
It is National Panda Day today. It's on our calendar.
Wow.
Today is National Panda Day. Blair's become a panda in honor of Panda Day. And do you know what time it is?
What time is it?
Time for Blair's Animal Corner.
She loves our creatures, great and small. 5-peg, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels that are both for her.
What you got, Blair?
Well, I'm gonna start off with a panda story.
Woohoo! Surprise, surprise.
But it is in line with my current views of pandas. So don't let the suit fool you. Pandas are quite disappointing.
Yeah, she might look like a cute, cuddly panda. She doesn't mean she likes them.
Yes. I'm not what you would call a panda enthusiast. That's because they're not very good at being pandas. So a new study has come out explaining another way that pandas are not great at their job. What's their job? To continue to exist as a species.
We gave you one job.
Yes,
One job.
One job. So a recent study from Michigan State University looked at GPS tracking in 5 pandas with special collars. And they looked over this long-standing study to figure out the movements of these pandas, because despite the amount of resources put towards panda research every year, we don't know very much about them because they don't seem to conform to many patterns. They just kind of exist. So usually with mammals, particularly with mammals where males search out females for mating, like other bear species, males disperse. When they grow to be adults, they move out, they find other territories, they claim those territories as their own, and then they find some females. And so we expected to see that in this GPS study as well. Well, it turns out that females and males actually disperse in a similar pattern, and in some cases, females actually moved farther away than males did. So, despite that, females still usually came back to their original home range to give birth and raise their cubs. The problem there is that this is very high risk for the females. In one case, one female ventured so far that she returned back emaciated, wounded, and later died before she was able to procreate.
Oh, goodness.
Yeah, so they're exhausting themselves. They're heading far away from where they actually have to come back later, or will try to come back later. Not to mention, this makes it much harder for males to find them. When females are in one place, males can track them. When females and males are both on the move, it makes it much more difficult.
Right, because they're both moving. There aren't that many of them. Are they going to run into each other, or are they not?
Yeah.
And the chances, the probabilities that they've got the amazing sense of smell, like moths to a flame, right?
Yeah,
it's very slim.
Yeah, so this just seems like not a great strategy, that they would be the only bear species that has female and male dispersal when they become adults. It's bizarre. Not to mention the fact that these guys live in mountain ranges, and a lot of times females will move high up into the mountains during the summer when it's okay for them to go up there, but they don't always come back down at the winter. And then they're up in the tops of these mountain ranges where there's very little food, where it gets very cold. They don't move back down to where they're supposed to be during the winter.
Why not?
This is the question. This is the question. Why? Why is this happening? What's causing it? Pandas, come on, guys. You have one job. Well, really, two. We want you to survive, and we want you to procreate.
Is there any possibility, though, that you are interpreting this research through a lens of bias, an anti-panda bias?
Absolutely. However, it is 100% true that this is the only bear species where we have seen female and male dispersal. So that's for real. It's also very unusual in mammals in general for this to happen. So it's a weird thing. Add it to the list of weird things with pandas.
Pandas, a list of weird things.
Yes, it's another way that they don't act like a bear, even though evolutionarily they're a bear. So remember, we found out earlier this year, I think, that they have all of the gut bacteria to eat meat, but they eat bamboo.
Don't. Right. They self-limit their diet. Why?
Yeah. So come on, pandas. Panda ladies, can you just stay put?
Somebody just stay where you are. Let the others wander.
Yeah. One of you, just wait. So So that's talking about panda movements. Now,
I like this. I especially this very go panda kind of story on National Panda Day. Good job there, Blair.
I have to tell you, I combed the science news for more panda stories. This is the only one I found. It's like pandas themselves are anti-panda. Panda researchers are anti-panda. Anyway, so there's pandas and their mating and GPS and dispersal. Frogs have a completely different method when it comes to their offspring. So looking at brilliant-thighed poison frogs. Brilliant-thighed poison frogs. Alobates femoralis. They're from the tropical forests of South America. And males guard large territories. So one male will have a territory that is his. There will be several females inside his territory. So he is, in theory, the father for all of those females. Then the females lay their eggs on fallen leaves. And after about 3 weeks, tadpoles need to be transported from the fallen leaves, usually on the backs of males, to the nearest body of water. Females will occasionally do the transportation of the tadpoles when males are not around. When the tadpoles need to be moved, where's dad? Not sure where dad is. Okay, the females give up and they do the transportation. So looking at a study looking at which tadpoles are going to get moved, this is a study out of Vienna. They wanted to see if the frogs were at all choosy about which tadpoles they move, or if they were just like, oh, these tadpoles need to go to the pond. Get on my back, let's go. So it turns out males are not choosy at all. Females are very choosy. Males assume, our assumption is that they are assuming that all of the tadpoles in their territory are theirs. So any clutch in their space, it's going to be their tadpoles. Jump on, let's go. Females, they actually remember exactly which leaf in exactly which spot they put their eggs, and those are the only tadpoles that they will transport. And the scientists studied this by messing with the location of the eggs. So they would have her eggs on the right side of this enclosure and another frog's eggs on the left side of the enclosure. And the female would always move just her eggs, the eggs on the right side. If they flip-flopped them, she still only moved the right ones. The ones on the right side, the ones where she laid them earlier.
Mm-hmm.
So
she's
even
not,
though they switched
she's
them.
not recognizing them specifically.
Right.
She's recognizing the place.
Right, but this does mean that the female frogs have an amazing GPS. So they remember exactly where they put their eggs in a dense rainforest. That's pretty impressive.
Yeah, and it stems from probably the female versus male behavior. Who is gonna, like, if you're taking, I mean, why would the male just take care of whomever versus the female be so choosy?
Right. Yeah, and especially if the male is the one with the main job of moving the tadpoles, he has a lot to do, especially because he has multiple females. So he's just very goal-oriented. Get the tadpoles to the pond. But since the female doesn't actually transport the tadpoles very often, they only do it if the male is not around, that would make sense that they have to do a little bit more problem solving of, is he going to come back, or do I need to do this?
The females don't guard the territory.
No.
It's just the males who guard the territory.
Right.
So, right.
Yeah.
The males are more goal-oriented also because they're like, okay, I got to do this job, drop off the kids, and then I have to get back.
Yes,
Wait,
exactly.
does that still take place in tadpole? I think you're anthropomorphizing
Oh no,
Maybe
not
just
at
a
all.
little.
Not at all.
Yeah.
Yes. So what we know is males, it is beneficial to them to move tadpoles within their territory, whether or not they're theirs, because chances are they are theirs. Not, I don't know what the actual number is, but let's say 9 times out of 10, if it's their tadpoles, then it's better for them to, rather than waste energy on trying to figure out which ones to move, to just move them all.
And to be fair, the male frogs didn't lay them there. So, they don't have a way of remembering it.
True, but it is their territory.
Yeah, but I'm just saying, I mean, that's one way that the female frog might be able to remember she was there.
The specificity of where the eggs were laid.
But
Yes.
see, before the study, we didn't know that it had to do with where they were laid. The researchers thought it might have to do with some other element of the egg. So if there was another element to the egg that the female was recognizing, then that could have been something that the male could have also recognized. If it was some sort of scent or marker, that's something that either of them could have recognized. But yes, it makes sense that since she's the one laying the eggs, it's more important for her to be able to figure that out.
Can I add some stories to the end of the Blair's Animal Corner?
By all means.
Of course, do it, yeah.
So, there are a couple of different stories that I thought were interesting this week. One in particular, a study on storks. And historically, we have stories of storks flying and delivering babies to people, right? Because storks were flying all over the place all the time. They migrated. They left and they came back in the spring, and these storks were moving all over the place. However, more recently, storks have taking up residence in certain areas and not migrating as much. And researchers decided it would be a good idea to figure out what was going on. Why did they stop migrating? Was it just climate change? Were they adapting to climate change? What's happening? Well, there could be, there are risks to migrating. And there could be some aspect to where they were going that have changed. But what they've discovered in Portugal, specifically, this stork population has grown 10 times over the last 20 years. It's multiplied. And now there are 14,000 wintering storks. And there are more and more storks coming. It's because they like landfills. Portugal happens to have nice landfills where people throw their trash with lots of food in it. So it's a food source. There are great nesting sites with lots of junk food, at the landfill. Anyway, they looked at 48 birds using GPS tracking devices, and they were able to get the positions of the birds 5 times a day, so they knew where the birds were going. They also got accelerometer information that detailed how fast they were moving from place to place, and they looked at where they were going, for how long, whether it was a long flight, a short flight, what kind of energy they were putting into it, to figure out the kind of behavior they were doing, whether they're standing and they're just cleaning themselves, or whether or not they're looking for food or tending their eggs or doing other things. And the researchers say storks now rely on landfill sites for food, especially during the non-breeding season when other food sources are more scarce. So historically what has happened is that food would become scarce and the storks would leave.
Right.
But now we dump our trash in these landfills, or Portugal does, and the storks have year-round food. Mm-hmm. So why leave? It's very nice. It's very nice. We have these meals. You walk up and you get the food and it is nice. You stay here in the landfill. It's okay.
This is something that we actually saw on my college campus. When I was in college, we had Canada geese that usually were only there for part of the year. And by the time I left, they were there year-round because they knew that people would feed them. And why go all that distance for no reason?
Why? Why?
Talking about doing what you're supposed to do as an animal in the wild is about surviving with the least amount of energy expended, right? So
Right.
that's winning.
It solves the problem. These are highly adaptable birds. The fact that they have changed their behavior, and not in a seriously long amount of time either. I mean, we're talking 20 years. This is not a long time period for this kind of behavior to have started, and to be for the population to really be growing the way that it is. Interestingly, birds find good nest sites, and they stay in the landfill. And while some birds may continue to migrate and leave, the ones who stay, they defend their nest site territory all year round, so that when spring comes, they've got good nest site habitat for themselves. So they're also using the food to maintain a good, to protect their ability to reproduce in the spring.
Yeah, and storks already have a highly adaptable feeding strategy. They're already omnivores. They already eat pretty much whatever they can find. So they're a perfect
candidate for this.
Yeah, they're a perfect candidate for this. Exactly. Yeah.
Now the question, though, is the European Union has brought up new rules regulating landfills, and there are going to be landfill sites closed. They're going to be closing the landfills, and human trash that contains food is going to be dealt with undercover, so there won't be any access for the storks to the food very soon. And so the question is, now that the storks have developed this new behavior, how will they adapt to this new human-driven change? Will they start migrating?
Right. And we have to ask, is there a negative result of them no longer migrating? Is the area they were migrating to that they're suddenly absent from, is that food web disrupted?
Right. We don't know. Yeah. Don't know the answer to that question.
Yeah. And I wanted to jump back to the frog story real quick, because I did look something up. So Justin, the male frogs would know exactly where the frog eggs were laid, because frogs and toads, most of them breed via amplexus, which is when the male rides on the back of the female and he fertilizes the eggs as they come out.
Aha, I see.
So he would know where they are, actually.
So, but again, that may be the only place where she had eggs come out, but that might not be the only place where. I'm just guessing. I don't know how frogs do. So they don't really have a good excuse, is what you're saying. They should know.
Right. Yes.
The males should know.
They could very easily pay attention to that.
Minor details. Wait, there were eggs involved?
Pay attention.
There were eggs involved? I had no idea.
Oh, boy. Oh, boy.
Oh, dear, oh, dear. And then another cool story, this one a little bit different, but again related to adaptability. There was a study from the Pacific Northwest National Lab in which researchers published in Public Library of Science 1, PLOS 1, looking at how microbes in soil might adapt to climate change. And what they did is they used an environment in which it was on a mountain. So they took soil from low on the mountain and then moved it up, soil from high on the mountain, and put it in boxes and moved it down. And this is an environment on a mountain in eastern Washington state where basically if you move up just 5 meters, or sorry, not 500 meters, the temperature cools by 5 degrees Celsius and rainfall increases by 5 centimeters per year. So just 500 meters up the mountain, which is not very far, you get a very different climate than further down. So this was a 17-year study. So 17 years ago, they dug up dirt from different places on the mountain and they stuck it on different places in the mountain. And they've been looking at it for 17 years, kind of just monitoring it, make sure nothing happened to it. What they found is that What do you think they would find, Justin, knowing
So-
what we know about microbes?
So I would say that there was different fungi in the soil, and that's what was affecting the bacteria. And that because of and then the different moistures and the different altitude temperatures, different fungi were setting up shop. And that is, I would think, what would influence the bacteria that could survive in that soil. That
Oh,
would be my
interesting.
guess.
More so than the climate itself.
Yeah, I mean that the climate would affect the fungi, and that would be the thing that would affect the bacteria you would see there.
So anyway, that's an interesting point, because what you think though about microbes is that microbes are resilient and adaptable, and that we think about our own population and we think about disease, and you think about bacteria and antibiotics, and the fact that bacteria are adapting to the pressures that we're putting on it with our antibiotics. But what about these soil bacteria? What about the microbes in the soil? Over 17 years, they found that the microbes retained many of the traits that they had in their native thermocline. So they didn't change much. They pretty much stayed the same. And the big thing is that, to a large part, they retained their original rate of respiration. Researchers said the fact that soil's native environment continued to exert profound influence on microbial activity 17 years later is quite surprising. This is co-author Ben Bond Lamberty. He's a scientist with the Joint Global Change Research Institute. We can't assume that soils will respond to climate changes in the way that many scientific models have assumed. So the microbes native to higher sites respire at higher rates naturally due to moister climate and more carbon in the environment. But then when they get moved down to drier, warmer sites, they kept respiring at that higher rate, even though there was not as much carbon and the temperatures were warmer and they weren't getting as much moisture.
Interesting.
Yeah.
So not a rapid
then-
adjustment taking place here at all. This
No,
is
I mean, you'd think over 17 years that they would have
17 years
seen.
in the life of a microbe. I mean,
Is
in
so
the
many
generational,
generations.
right? Yeah. Wow. That is
Yeah, so-
surprising. I would not have expected to be not the change.
So we don't know why, though. So you brought up fungus in the soil. Maybe that it's not the climate that is going to affect the soil bacteria so much immediately because of the populations that they live with in the soil. Maybe because of the synergistic effects of whatever other organisms they exist with, the fungi or I guess I should say funguses, whether or not they have any kind of special relationships that affect respiratory rates or metabolism in any way. Maybe that does have a higher effect than climate.
And then that would sort of make sense that
time
if
period.
you're bringing the fungus with you, you're also bringing the fungus with you. I mean, you're sort of keeping it in the same thing would be affecting it. It would be but the fungus could be the same. I mean, I don't know. These are complete speculations. But when they moved that soil, they moved not only the bacteria but all the fungi that was in there as well.
They moved everything. They picked.
Yeah.
They dug up the dirt and they moved what they dug up to a different place.
So then what I would want to know is there any difference in the fungi that are present in the soils up higher than down low?
Right.
If they're the same, then that doesn't explain anything. If they are different, then maybe we have an idea.
Yeah. So that is a great question. That's a good question. I don't know the answer to that. Yes. I believe that is further direction for this research. to
Possibly,
actually-
but over 17 years, I'm sure that they've got that sorted. I mean, they had 17 years. I had a minute and a half. I'm sure the fungal difference didn't come into play. But if we were proposing this without having known how long it was going, I would say maybe there was a good shot.
Yeah, so I mean, I think they did look at bacterial populations, at what organisms were there, but and they looked at enzyme activity. to see how things changed over time. But yeah. Meh, meh. Not much difference. All right, Justin, do you have any more stories?
No, I'm pretty much out of stories. There is a quick, there was another one. I'll just kind of just brief it. There's a study reports significant link between nightmares and suicidal behavior.
Ooh.
Yeah. I said results show that suicidal thoughts, plans, or attempts were present in 62% of participants who experienced nightmares, and a much about less than 20% of those who did not have nightmares. So nightmares are perhaps a big signal that something is going on. It says also nightmares may trigger specific types of negative cognitive thoughts, such as defeat, entrapment, hopelessness. Also, real life defeat, entrapment, and hopelessness can affect dream state, reiterating what's going on, which reinforce suicidal thoughts and behaviors. Pathways between nightmares and suicidal behavior appear to operate independent of comorbid insomnia and depression. So it seems to be even, and you don't necessarily get nightmares just by being depressed, but that if you do have the nightmares, even if you don't feel depressed, you might want to take a look at stuff.
Yeah. I just think about waking up from a terrible dream and having to start your day and how it just ruins the whole day.
Yeah.
It can completely change your outlook on everything. It really messes with your brain.
Well, that's a bummer. But I think what they're tapping into is there is like tape loops that people can sometimes not get rid of. Negative loops, negative internal criticism that replay and replay like a stuck record.
Right. But I wonder if from this that means we can also identify what can cause these really detrimental nightmares, and if maybe we can actually keep them from happening.
Possibly, but I think the nightmare is more of the symptom that you'd want to be able to see.
I'm just imagining people. Right. I'm imagining people like getting upset at their nightmares and being like, "Trigger warning! Come on, trigger warning!"
Yeah, but also like if you're having a lot of nightmares, it might mean that might be not just something you ate before bed. I would it'd be awful. I don't know. I have a lot of fun while dreaming. So
dreams are fun.
I can't imagine being sort of put through the ringer or terrified while I'm sleeping.
Speaking of nightmares.
Yes.
Spiders.
I don't like spiders.
I love spiders.
No, guess what? I like spiders. I do.
It's okay because a lot of them, it turns out, eat plants.
Wait, what?
Yeah.
Spiders eat plants?
Yes. Zoologists from the University of Basel, the US and UK, have now shown that a wide variety of spiders include plants in their diet.
Wow.
So
that
we know
just changes so much.
Right. It totally changes the way you think about spiders. But of course we think of them as mostly insectivorous, but we also have seen them eating things like fish, frogs, bats, occasionally birds. There's the bird-eating spider.
But that all makes sense because spiders eat meat.
Right. But it turns out many of them eat plant matter. They eat trees, shrubs, weeds, grasses, ferns, orchids. They also will occasionally eat nectar, plant sap, honeydew, leaf tissue, pollen, and seeds. The most prominent group of spiders that they found eating plants were Salticidae, which is a diurnal spider with large anterior median eyes, and that family had up to 60% of their diet turned out to be plant matter. Yeah, yes. So this is just, it's widespread. They found plant eating by a spider on every continent except for Antarctica so far. So it's widespread.
There probably aren't that many spiders in Antarctica.
There's not a lot of spiders in Antarctica.
Not a lot of plants in Antarctica either.
No. So spiders, plant eaters, turns out.
Wow. Obesity. We've talked about obesity, diet, epigenetic inheritance on previous occasions. There is a report out in Nature Genetics that seems to be a fairly landmark study, the way that they designed the study. So researchers took genetic clones, mice breeds that are basically identical mice, and they used in vitro fertilization to get rid of other factors like paternal seminal fluid or diet-induced changes in the uterus during pregnancy. So they had a group of mice eat a high-fat diet and get fat, and another group not do that, and then used in vitro fertilization to make babies from these different groups of mice, and then they looked at the offspring, giving them a normal diet for their developmental period, and then feeding them both a high-fat diet. So the group that came from the fat developing parents ended up gaining more weight and having developing more of a diabetes-like profile than the parents that had been on a control diet, offspring from the parents who went on a control diet. And so it's I think this is a wonderful study. Mice, not people, of course, but a wonderfully controlled study, getting rid of kind of the extraneous factors involved in what could influence the epigenetic inheritance, what could be influencing it. And so there are things that happen during an animal's lifetime, like metabolic disorders from eating a high-fat diet, that can have effects on the offspring.
So eat healthy until you've had your kids, and then
then
it don't matter. Then do whatever you want.
Exactly. And then not a study, that we talked about it very briefly at the end of the show last week, the AlphaGo competition, with Lee Sedol, one of the world champions in the game of Go.
Mm-hmm.
4-1.
He won one.
Lee Sedol, not AlphaGo. Lee Sedol, the human, won one match.
Yeah, take that, robot overlords. Yeah.
So he got what? He had 20% success rate.
Well, it's not what the robots were shooting for. I'll tell you that. I'll tell you that right now. Okay? That means there's hope for humanity.
Yeah, take that, Agent Smith.
Right? Yeah. Well, look at it. That's a perfect example of all the millions of sleeping humans in that whatever thing it was, the Matrix.
Yeah.
There's only one that could break the code, right? There you go. That's all we need for humanity to have hope in the future.
It's an amazing, amazing match that has occurred. Nobody expected a computer to be able to best a human in one game, let alone 4. No one expected a computer to best the world champion in the game of Go yet. This wasn't supposed to happen yet. This is a little faster than people expected. So that in itself is interesting. A few interesting insights that came from this. The game that AlphaGo conceded to Lee Sedol, the people from Google who run the computer, they pretty much said that AlphaGo made one big error at the beginning of the game that was disastrous and wasn't going to be able to come back from, and they were going to fix that.
Okay, good.
That won't happen again.
Yeah, come on, guys.
The Moore's Law of this, though, as I'm going from, early computer chess playing to, the Deep Blue to this, total and complete world robot domination by 2045.
Possibly. Possibly. The other insight to this particular battle, this Go battle, is that the computer definitely did not think like the human Go masters. And the reporters who have been reporting over the past week on these matches have commented many times on the Go masters who have been watching the game, and it's sometimes been absolutely overwhelmed by the beauty and complexity of the moves that AlphaGo enacted, while other times being flabbergasted at the simplicity and the what they would call weakness of the moves. Because human players go all out. Every move is supposed to be strong. Every move is supposed to say something. This is a battle. Whereas AlphaGo's whole goal was simply to win a match, not to do it in any particular way. So there's no the nuance of the human game was not there.
There is no try. It was only do.
Yes.
Or in this case, go.
In this case, okay, go.
So speaking of games, would you guys want to play a video game with an orangutan?
Sure, as long as I
feel
was
like
not...
it's a,
sure.
Yeah, I feel like it's a let the Wookiee win scenario, but okay.
So in the zoos in Australia, Zoos Victoria, so that's the Werribee Open Range Zoo, the Melbourne Zoo, and the Healesville Sanctuary, they have worked together on using computer games and video game systems for apes and other primates at their facilities. And in particular, there's orangutans that have really responded well to using the Xbox Kinect. And there's a couple games that they've used with these orangutans. One is where you grab at dots of color and then they explode into a bunch of colors or something fun happens. Or another one is they actually get to pick between pictures and videos what they want to see. And there are other games where they actually get to interact with people that come through the zoo. And researchers have found that these orangutans, they all interact differently with it. Some of them will use their hands, some of them will kiss or touch with their lips the various things. Some of them will take objects and wave those things at them like a sheet or a bowl. But they all figure it out really quick, and they all actually really enjoy the part where they interact with the game with someone on the other side of the glass. And it doesn't have to be someone familiar. It can be a random person walking through the zoo, which really shows you that they can use this technology really well, they enjoy doing it, and that they catch on to the interactive aspect right away, especially when there's a third party that is a human on the other side. So this is a really great tool for enriching the lives of animals in captivity, but I think this is also an amazing opportunity to develop a way to essentially communicate with these animals. They can set it up so that these animals can
oh my God! Soon they'll be playing Minecraft and third-person shooters. It's going to be crazy. First-person shooters.
Kind of terrifying. But when you use it to decide, so that they can tell us when they're hungry, so they can tell us when they need enrichment, when they're bored, that part's really amazing. And especially because we don't have people looking at them all day, every day, day and night, they can take care of themselves to a certain extent if we're not around and they're bored. But this also means that they can totally start to tell us things. So we can learn so much from them, and I think eventually this could help us actually have a dialogue with animals that we would never have expected we could.
Hey, we're going to be interfacing with artificial intelligence and orangutans.
Yeah, well, imagine having a conversation with a pigeon. You could actually do it.
Peck by peck.
Yeah, pigeons learn touch screens right away. I think it's fantastic. It's crazy.
Conversations with animals through pecking and poking.
And awesome. I love this for the orangutan too, because it's at the Sacramento Zoo, they don't even come out anymore. I hope I don't know that. I hope I'm just not knowing that they're gone, that they died or something. But they seem like they were the most disinterested. They would hang out near their opening, like the little, because the animals at the Sacramento Zoo can always pretty much all leave if they want to. They can all go back and hang out in their internal behind-the-scenes cage area, whatever it is. But the orangutans are never out. There were 2 of them. They're never out. And I go to the zoo pretty much weekly. So and
They're all playing video games.
Yeah.
That's why.
yeah, they're all inside on the
They're
Xbox.
inside on the Xbox.
Yeah,
That's right.
why they're gone. But yeah, so I love anything that gets gets them excited and interested, because they do not seem to enjoy being at the zoo.
No. Have we done it?
That's all I got.
2-hour show, folks.
I think that was it.
Work. That's all we wrote. I would like to take this opportunity to thank our Patreon sponsors, and special thanks to all the new names in the list. It's always neat to read new names that I haven't read before. So thank you to Kevin Parachan, Keith Corsell, Steve DeBell, Wandered White, Patrick O'Keefe, Jason Schneiderman, Rudy Garcia, Gerald Sorrells, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Patrick Cohn, Chris Clark, Richard Onimus, John Ratnaswamy, Byron Lee, E.O., Bob Calder, Jared Lysette, Ulysses Adkins, Brian Condren, Jake Jones, Trainer84, Kati Volk, Edvitus Rimkus, Brian Hedrick, Cassie Lester, Sarah Chavez, Layla, Shane and Tara Ginsburg, Marshall Clark, Charlene Henry, Don Conmorachka, Larry Garcia, Randy Mazuka, Ed Dyer, Tony Steele, Dave Friedel, Craig Landon, Daryl Lambert, David Wiley, Robert Aston, Flying Out, John Crocker, Richard Porter, Christopher Dreyer, Andrew Dolinger, Sylvan Westby, Artyom Pixelfly, Shu Wada, Stephen B., Dave Wilkinson, Steve Mashinsky, Rodney Lewis, Braxton Howard, Phil Nadeau, Rick Ramus, Sal Goodsam, Matt Sutter, Emma Grenier, Philip Shane, James Dobskin, Kurt Larson, Stefan Insom, Michael George, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, Alex Wilson, John H. Maloney, Jason Olds, James Noah Wiles, Paul West, Alec Doty, Illuma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, David Simmerly, Tyler Harrison, Ben Rothig, Colombo Ahmed, and Gary Swinsberg. Thank you for all of your support on Patreon, and if you are interested in supporting us, you can find information at patreon.com/thisweekinscience. Remember, you can help us out just by telling your friends about TWIS. On next week's show, once again, we'll be broadcasting online, live at 8 p.m. Pacific time, and I guess now that we've had a time change, Pacific Daylight Time. Yes, on twis.org/live, where you can watch and join our chat room. Don't worry if you can't make it. You can find our past episodes over at twis.org/YouTube or the audio episodes at twis.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have an Android, look for TWIS, the number 4 droid, app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts as well as other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there is a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from today's show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And now it's time for the after show. Hey, Whiskey Renegade, that's totally the look I was going for. I was going for virtual reality helmet. I think it works, right? You can imagine me in 360. I am in my own head right now. I can see the whole world in just this little helmet. I never have to go anywhere ever again.
I was thinking of Geordie LaForge.
Oh, virtual reality helmets. A friend posted a picture of his son, who's 7, sitting on the couch playing a game using a virtual reality helmet. Are you taking a picture of yourself as a panda?
Yes.
Blair's selfieing with her old calculator phone.
You know.
Ben
Rothig,
cost per use. This will come down. It just comes down to cost per use. Do you know how long I have had these AKG headphones? I think that now they're like pennies on the dollar. Pennies. I've used them so I will be so sad when these stop working because they're amazing.
I used them a couple times at your house. It's amazing.
And they envelop your ears. What was Ed's idea? Do the panda? a virtual reality TWIS where we are all a virtual studio. I love it.
Ooh, I like that too.
That'll happen someday, right?
Yes.
Where what? What's the idea? I didn't get it.
Where it's virtual reality, where we are like all
Isn't this
together.
already virtual reality? Where
Yeah.
we're all together. Like I don't.
No, but like people will be wearing their cool VR helmets, you know? And we'll be like right in front of them and next to them, and they'll be sitting with their friends in the studio audience.
And we'll have avatars instead of
It would have to be avatars.
themselves.
Well,
I still want to be me. You two can be avatars. You
we
can
could
be
do that. We could do that now. We just join Second Life, right?
I don't know.
That's scary.
We could do avatars and do a TWIS podcast in Second Life.
Okay, we should do one like that.
Wouldn't it be fun?
Would they be like moving and talking while we are? Is that the idea?
Yeah, totally.
I've never. Second Life has been around for like as long as this show has been on the air. I think
Pretty
it's
much.
been on for. Do people?
been
I've
around
never
a
even. I've
long
never even
time.
looked at it. Now I have to Google it. I've
It's
never
been
even looked at it.
around. I had an account a long time ago. I never canceled it, so it's probably still there.
Oh, your
Wouldn't
poor
even know how
avatar is
long.
probably starving to death.
Yeah. Second
Wandering
Life
like a
does
zombie.
still exist, and it has a population of over 1 million, as far as I know. Like,
Huh.
constantly in it. As far as I know, it's not huge. Like, it's not like Facebook where it's like billions of people, but it has a constant population, and it's still there.
Huh.
I don't know how much of it is a ghost town now, though, or if they've revamped it and gotten rid of things, or what. But then, what is Philip Rosedale doing now? It's not Second Life. It is for virtual reality. I'm blanking on the name of it. Oh, cool, Arnlore. Cool. Yeah.
What's happening? Oh no. All right,
What?
that's not bad. I'll take it.
You'll take it?
It could be much worse.
Blair Panda. I needed 1280 by 720 for my custom thumbnail.
Ooh.
I'm working my way slowly, as quickly as I can, but I'm taking an online YouTube boot camp for growing audiences.
Huh.
Yes.
Nice.
So, did you see my tweet or my Facebook posts earlier? Check out here. I'm going to put the link to the most recent show. I've probably got the tweet here somewhere.
When would this have been?
Earlier today.
Okay, I might not have seen it.
I haven't.
Here,
been
I'm
on
going to
the-
copy the link. Hold on. So here's the link to last week's episode. And so I put it in the chat room. And if you go click on that, don't watch the video, but just scroll down to the description. I want you to check out what I did in the description. I think it's going to be cool. I think it's going to be...
Ooh.
Right?
Whoa. It's not the sperm, it's the semen that matters. Whoa, it says Blair's Animal Corner is at 25, and then... Oh, then the next story. So, I see. It's at 32.
Yeah. So you can go to the stories or sections you want to go to.
Oh, and it's linked? Oh, it's linked!
Click on the time. Click on it.
Wow!
So you
It's
can go
like we're in the
directly,
21st century.
right? You can go directly to the part of the show that you want to hear.
Wow.
Isn't that awesome?
That's friggin' awesome.
I had no idea about that until I was taking this boot camp, and I'm like, oh, what's this? I have to try that. I'm like, oh my gosh. So thanks, YouTube, for having a boot camp, because I learned something. It's my professional development period right now. I've decided that I've been not doing enough professional development lately. I need to professionally develop more.
Nice.
Yeah. Yeah, but that's cool, right?
Yeah.
Timestamps, fancy timestamps.
Dang.
Yeah.
Ooh, Space Monkey followed me.
Yay! Awesome.
So wait, okay. I'm looking at the link. I'm seeing that to
You
show
like
up.
my titles? It's not the sperm, it's the semen that matters.
Is that what Dave wants on a t-shirt?
Probably.
Yes!
Hey,
Semen
how do
does a body good.
you?
Seminal fluid
That's right.
hydrates.
What, Justin? What's
How
it
do you
in the-
jump to the spots you want? I don't see it yet.
You click on the
Are you-
timestamp.
So if you go down to the description and you hit show more,
Oh, gotcha.
and then there are times before each of the topics.
Okay, hang on. It's my resizing problem here. Hang on. Let's see. Then I go to show more. And oh yeah. Oh, that's so cool.
Isn't that cool?
That's so cool.
That's like a new show development. I'm like, wow. Yeah, so I don't know. I can edit out little clips, but
Semen.
make
It's
things.
got electrolytes. Oh my god.
Identity 4. Yeah, so
I could keep going, but things would get out of control. I'm gonna stop. They just keep coming. Oh!
Oh.
No. You didn't.
I didn't realize until I said
Yes.
it. Oh no. No. I'm usually so good. Oh no.
Once you pop, you can't stop it.
Oh no. Stop. This is not appropriate.
Yeah, Rights for Robots. Bad zoologist. Oh my goodness. Oh, a shouty Blair picture. Where's that? Nice, Dave. All the Blair panda pictures. We have a shouty Blair picture.
Where did those come from? Where is it?
Oh, you haven't noticed all the images that people took of you?
No.
Yeah.
Although,
We have a whole slew of them now.
We've got a library.
are they all on Twitter now or what?
One of them is.
Oh no. No.
Yeah. So you guys talking about the time change. It's so funny. I never, ever used to differentiate between standard time and daylight time until I started scheduling interviews with people in different time zones. That is Pacific. It's just Pacific time. Don't you know what Pacific time is? It's just Pacific time. Do we have to say it's standard time or daylight time? Does it really matter? But I was scheduling interviews with scientists, and I would get people writing back like specifically standard, PST, PDT. It's Pacific time. It's whatever it is. It's Pacific time. Or it's Eastern time. You guys, figure it out. Is California going to give up on the time change?
I hope so.
I know, right? It's this video from Rights for Robots. What have you done? Oh, yes, little girl blowing kisses to a lion at the zoo. That lion wants to eat her. Rawr. That lion wanted to eat that little girl. She was threatening him.
Yeah, that's less than ideal.
Right? I always wonder, when they have these bits of glass.
I like the shouty one. Where did this come from?
Shouty
I
Blair.
need it. Who took it?
Isn't it on Imager? You just
Ermagerd?
just download
Ermagerd
it.
Panda Blair?
Shouty Blair, download it.
Where?
It's at the link. Can't you just?
Which link? Oh, this one?
In the chat room, Dave.
Oh, there we go. Found it. Okay.
Get it, and then you go shoink. That's a download.
Oh my god. I sent a new profile pic for my Shouty Blair Twitter.
Shouty Blair, shouting like a panda.
Oh my gosh. Yep,
Yeah.
doing it.
Hey everyone, Ed posted the Minion Hangout link earlier in the chat. ScienceIsland.org, science-island-chat. Look for the Science Island chat at scienceisland.org. Or you can look for the Minion Hangout YouTube event. Tomorrow, they're going to be talking about some cool stuff. I know he posted in Facebook an outline of what's going to be on tomorrow. Some interesting stuff. Don't miss it. Arnlore, okay. Right, in mountain time, nobody pays any attention. Everybody leaves the central time out, mountain time. They're like, what? What's this other time zone? The one in between the two time zones. It's like the opposite of the Oreo filling.
Explain?
The time zone that nobody cares about.
Oh, because the filling is normally what everyone eats, and then they don't eat the cookies?
Exactly. The opposite of an Oreo cookie.
Yeah, Dave, you should sing the Tracy Ullman song.
Timey-wimey. Oh, another Blair Bell. That's the same one. Blair Bell's shouting. No, not change its time zone, Whiskey Renegade. Just not do the time change anymore. So just leave it as it is. Polar bear tried to escape from the Cleveland Zoo.
Mm-hmm.
That's
yeah,
not
but
good.
they only made it into secondary containment, which is why secondary containment exists.
To catch polar bears.
When primary containment fails, they're still contained, and then they can just tranquilize them, move them back in, fix what the problem was. This is why there's secondary containment. But the zoo did it perfectly. They, when they found out that it happened, they were able to round up everybody in the zoo. Everybody sheltered in place. Once the issue was deemed stable, and they knew that the polar bear was contained in the secondary containment, people were allowed to leave. Then they were able to move the polar bear back where it belonged, fixed all of the containment issues, and then the zoo opened later that afternoon. So it was fine.
Why did the polar bear decide to break out of jail?
Well, I wouldn't call it jail, but
containment.
Polar bear is a predator, and they are, if they're not engaged in other activities and they see an opportunity to move into a new space, a predator will do that. I don't know the specifics of what the issue was, and I believe they're still doing investigations to figure out exactly how it happened. But the good news is this is why zoos have secondary containment and they have escape protocols. So when these kinds of things happen, then it runs like a well-oiled machine. Everything is done as it should be done. Nobody gets hurt. No animals get hurt. It worked out perfectly. And I would also give the Cleveland Zoo props for having tweeted it out and shared it on social media right away, got ahead of any news so that there wasn't any miscommunication about what was going on. That means there was no panic. That means everything was very clearly indicated to people trying to get out and people trying to get in, and they owned up to everything right away. And I think that was done really, really well.
I think it's communication and just being straight about stuff is always the best strategy. You know, it's that kind of trying to hide things and not being clear with the public that gets people upset. Because it never works out well. It never works out well ever. I mean, this is a lesson we all needed to learn when we were like 4. You know, just come clean up front.
Yeah.
Don't lie about it or don't try and hide something.
But I think people, you know, it's very easy the way our media system works, people to get worried about, you know, any bad news getting out and it getting blown out of proportion and it turning into something bad. And, you know, it scares people sometimes. But I think, yeah, this is a great example of it doesn't matter what somebody might turn it into. It's better to get ahead of the gossip and just explain exactly what's happening and own up to it right away.
Mm-hmm. Own it. Identity 4 says we have a 2-hour, 6-minute show tonight. Woohoo! That is a record.
No,
Is it?
no,
I don't
no.
think so.
It's not a record. It's not a record.
For an official show?
Oh,
I don't
for
think
the
so.
not including after show?
Not
Yeah,
including after
Not
show.
including
just
after
the
show, but
Ah,
I don't know about that.
okay. We had a 22-hour show once, I think.
That doesn't count.
Yeah, that was different.
That was a broadcast. That wasn't. It was a 22-hour
only-
broadcast.
Yeah.
It wasn't a 22-hour episode of This Week in Science. It was very different.
Horror and lore. Oh. My father has antisocial personality disorder, and even worse is a salesman. I never learned well about lying being bad.
Somebody described lying
Oh, dear.
versus selling to me.
Versus selling.
Yes, if somebody's contemplating jumping off a cliff, and you tell them that if they do it, they'll survive, that's lying. But if you tell them it'll be fun to jump into the air and not and sort of as you fly down you'll have fun, that's selling.
You just don't talk about the truth.
You don't talk about the ending.
Yeah.
You don't include the whole
Avoid
story.
the details you don't
But
like.
the jump is really going to be fun. It's selling versus.
Yes.
My, oh, my, oh, my.
I heard this car doesn't have working airbags. Well, what's really cool about this car is that it has backup cameras.
Did
So
you see the
almost
radio?
never.
Did you listen to that radio?
Yeah.
It's a great sound.
Mhm.
Just move on. Keep moving.
This thing practically drives itself. You don't need to worry about it.
I've been invited to speak at a meeting for a regional electronics salesman conference.
Interesting. What do they want you to talk about?
So I did this show, How to Win, and
Yeah.
somebody saw that, and so
Mhm.
they want me to talk about the kind of psychology and brain aspects
Mm-hmm.
that were
Nice.
discussed. So a lot of stuff that would relate to being a salesperson.
Nice.
Yeah. Or more so, how your clients might might figure out your tricks.
Oh man.
Yeah. I don't know. It would be fun. It was a fun that I got this email out of nowhere, and I'm like, that's an interesting request. What should I tell them, Justin?
Yes. Say
Im-
yes.
Tell them yes, but they need to pay for our flight to experience zero Gs.
Right. That's good.
Or they could just, you could have a speaking engagement suggested donation to the TWIS fund.
Exactly. World's largest private coal miner going bankrupt. Yeah, that's awesome.
Poor guy.
Bummer for him.
Bummer for him, but not so poor. I mean, I'm sure the bankruptcy is just a corporate bankruptcy and not a personal bankruptcy.
Yeah.
That kind of stuff doesn't work. Doesn't really affect the individuals at the top of the food chain the same way. Hot Rod, oh my gosh. Your drunk employer always says that his truck drives itself, so being drunk isn't a problem. Not yet, no. We don't have autonomous vehicles yet. No. Maybe like the government does, but we don't. Panda Day! It's Panda Day! Hooray, hooray for Panda Day! Put on your panda coat and tails and run away!
Whoa. Where did this come from?
I don't know. One of those strange little places inside my brain where suddenly a song percolates up about Panda Day.
Who?
That's right, Dave Freddahl learned it from the TWIS calendar. Oh, what do I need to do? Things I need to do. I need to populate future Hangout events, right? Because I forgot to do that so that people know that it's coming. I need to post the show tomorrow. Learn more things about YouTube. Yeah, Blair needs to do the spider dance and the panda dance.
And I've got to go. My headache medicine is wearing off.
Oh, you have a big headache.
I have a headache and a fever of some sort.
Oh,
I've been,
fever's not good.
No, it's not. It's mild. It's not like I'm dying of it. But yes, I'm starting to re-deteriorate again.
Oh,
so
no.
I better go take more pills and go to bed.
Okay.
I will see you all next week. Same bat time, same bat channel. Good night, minions.
I'm
Good
ready
night,
for
chat room.
bed.
Sounds awesome. Yeah. Annotations. Somebody's got to do more things. There's more things to do. But I hope you feel better, Justin.
Well, I will. I'm sure. I
You're
better.
going to. Get some sleep.
Why do it stays this way? I know I have a headache for an hour, and then I start squinting because of the pain.
The headache face. Justin's headache face.
I better be careful. I don't want to get screen captured. All right.
Yeah. It's 10:30. We could all go, yeah?
Yes.
Yeah. Okay. All right, you guys. Thank you. Thank you so much for joining us tonight for the show. Thanks for being a part of the chat room. Really enjoy having you around. Good night, everybody. Blair, thanks for being a panda.
Of course. Happy to oblige.
Happy National Panda Day! Ta-da!
Ta-da! And not again for another year.
That's right. But this Sunday is International Day of Happiness.
Uh-huh.
So I hope that TWIS will bring people joy and happiness on
I'm
Sunday.
sure of it.
And no matter what, make sure to spread joy germs on Sunday.
Okay. All right.
Joy germs are the thing to spread. For
How
happiness.
do I do that? Smiles?
Lots of smiles. Be nice to people.
Compliments? Open doors for people?
Yes. Random acts of happiness or kindness. Random acts of kindness make people's days nice and spread happiness.
Yay.
It's the joy germs. Or, if you just happen to let go a giant group of multicolored balloons into the sky, people will see those and go, oh, that's beautiful. Yes. Ha ha. All right, everyone. Well, you've added effects. What are you doing?
I'm trying to bring joy.
You're bringing joy. Joy and pain. Sunshine
No, that's terrifying.
and rain. The
Hold on.
rich
Here we go.
raw bass.
Yeah!
Joy and pain. Sunshine and rain. I wish I could
Okay.
remember the rap that goes with that. Ah. There you go. So much joy.
Yay!
So much. There's just so much. This is joy juice, joy sauce. Oh my goodness. Wow. You're on a beach, snorkeling, having a snorkel party with your beard. Hey, let's take this beard snorkeling. Hey, am I a devil or an angel? I don't know, but I'd like to think about things. Check out my glasses, baby.
Oh.
Now I am pirate dog with a monocle. What?
Oh, yes, I'm a fancy dog.
I am a monocle dog. And now I am the cat in the hat with a beard. What you think about that?
I know.
No.
The randomize is the best part of this thing. Oh my gosh. It's great. It's great. Look at it.
This is like TWIS Snapchat, except it's going to be on the internet forever.
Justin's going to be so sad he left. Pirate dog again. This is like a favorite.
It is. Why would you randomize the pirate hat and the dog face and the mustache? Oh, it's a mustache, not a monocle.
Oh, here's a dog that graduated and wants
got
to
a
blow
cake.
candles.
I get cake. Oh,
Oh, boy.
I wish I could. I can't. I don't have the time for Snapchat.
Oh, Snapchat is great.
Do you use Snapchat?
Yeah.
I bet you do. Do you just
I certainly do.
spend a lot of time doing random things like this?
Uh,
Or is it actually
Yeah.
useful? Snapchat
No.
is just for like putting funny pictures out for a second,
Yeah.
right?
it's just, that's the thing about it that's different is if I tweet out a picture, then people can see it forever. But if I do a Snapchat to a friend of mine, then I know exactly who's getting it and
Mhm.
it cannot be passed on. And if they take a screenshot, I know about it and then I can call them up and yell at them.
Right. But here, you don't care. Oh, this one's good. This is like a punk rock scuba beagle.
Yep.
Scuba
Yep.
beagle's punk, man.
Oh my God. I just love that Google Hangouts has put so much effort into this.
And
But-
this will go down on your permanent record.
But then sometimes I can't stay in the Hangout. But I can be a funky barbershop cat in the hat.
Would you like people to follow you on Snapchat?
Oh, they could.
You could share your Snapchat
Okay.
address if you are interested.
Mhm. Sure. Sure, that's fun. Let's see. Oh, I know what
Ben.
I can do. So on Snapchat,
Your eyebrows are down, like you're really thinking about this. You're looking at the screen, eyebrows down.
let's see. My Snapchat is Blair Baz. Shocking. And Goldizator already added me.
Awesome. He found you
Yeah.
because Blair Baz.
Yeah. And I think you can use this now if people can. It's not gonna. No, it's not gonna work.
Oh, I see the little picture there. What? It says Blair Baz Durich. How does that work?
You can take a picture of it on Snapchat and then it finds me. 'Cause of
Really?
The dots. It's like a QR code.
Oh,
Yeah.
interesting. Well, I had Snapchat for a while, Hot Rod. I did. I started it, and then my phone got funny. Do I still have Snapchat on here? I might have deleted it. I was trying to make room for things. I think I might have deleted it. I need to delete Meerkat. That's the next one.
Oh, Meerkat, did that not work out?
Yeah, I'm not in. I mean, Meerkat could have been fine, but if I do anything, I just use Periscope because it's linked to Twitter.
Oh, that makes sense.
So I just Periscope if I do something.
Oh,
But,
I stopped on the clown? That was unacceptable. I hate the clown.
I deleted the Snapchat. I
Yeah.
had it, and I realized I wasn't using it, and so I went delete. I should probably put it back on there, but I'm sure there are other apps that would be more interesting. There we are with the scuba beagle again. Scuba beagle! Yeah! I like the Instagram. Instagram is one I like.
Oh,
Gotten into doing
my
that.
Instagram's way better than my Snapchat, but both are Blair Baz.
Am I following you? I'm the Dr. Kiki
Haha.
on Instagram.
Just in case anyone was curious.
Yeah, because somebody else took Dr. Kiki. Bummer.
Oh, there's the punk rock scuba beagle. Dave screen captured it.
There, Blair Baz. We follow each other. There you
Oh, good.
are. I never see your pictures.
Oh, I've been bad about it lately,
Maybe that's why.
but I do post. Oh, this might be my favorite.
With the crown.
The mustache and the glasses.
Because we could be royals.
Oh my god, when I move my lips around, it changes the axis that everything's on. Watch. Oh my gosh. Technology.
Following your face.
My goodness.
Yeah, that kind of stuff is going to get more and more interesting. It's going to get more exact. And it's the kind of stuff which, why am I blanking on the successor to Second Life's name? I'm totally blanking on it. It's Philip Rosedale's current company and totally blanking on it. But it's virtual reality and they're doing things like the eye tracking and face tracking and like stuff to track hand movements so that your avatar could actually really represent you in a virtual space. Yeah, some really neat stuff happening. Wait, why do we need to get Blair a real cheeseburger?
Oh, because I ate a tiny gummy cheeseburger.
I know what happened there. It was so tiny.
So I went
You were Alice in
to
Wonderland all of a sudden.
yeah, I went to a store where they had these old or these little, not old. They had these little gummy hamburgers that I used to eat occasionally when I was in middle school. And I saw them and I got kind of this like funny flashback. So I bought one and I ate it.
Nice. And now you have a cake. I like this one.
Cat with a tiara.
And the glasses. I like it.
My goodness.
Oh, what's this one? Blair King. There you are. We've got
That's a
some
good one.
good ones. Oh, Dave, this is fantastic.
Oh, oh, 3 new friends.
Yeah, you have 3 new friends on Snapchat.
Fun.
Oh, gummy burgers. Oh, we have a new joiner. Thee is in the chat room. Hello, Thee.
Oh, Thee left already.
Oh, Thee's gone already.
Yeah.
Thee was here. Thee left. I'm confused. No. Did Thee leave? Yeah, Thee asked about what we thought about essential oils.
Oh. What?
I don't know what I think about essential oils. I think the idea of essential oils is very interesting and that the scent, and we do know that there are effects in the skin for some things, right? We had that study a while back.
Mm.
I was talking about, like, I think it was it frankincense or something. There was a couple of essential oils that it looked at that it actually found that it stimulated receptors in the skin. So essential oils, I believe it's one of those areas that there's not been enough research yet for us to really say anything scientifically. But I don't know. I mean, this psychology of odor, how different scents allow you to feel differently, that kind of stuff. It can. No, it's interesting. What do you think, Blair?
I don't know.
No,
It
just a pirate.
It seems very. It's hard. I don't want to judge it based on literally no evidence.
But I mean,
this is science.
There are active ingredients in these oils from the plants that they come from.
Yes. It seems reminiscent of homeopathy to me.
Totally.
And homeopathy scares me. And I generally speaking don't like it. Because it indicates that there is a replacement for actual medicine.
Right.
And I don't like that either. And if you talk about essential oils as part of a supplement process, then it's okay. Because then you're just like, you're not expecting vitamin C to cure your illness. You're just trying to boost your immune system. So if it's looked at in kind of that lens, I think it's okay. Right. But if it's looked at as medicine, that bothers me.
Right. Yep.
Dave, nice screen capture.
Har. Randomize is fun.
Yeah, it's very fun. Oh.
What do you think, Beard?
I like the beard.
I live in Portland.
Wait, we both have beards.
You look like a tennis pro who lost an eye. You're a tennis pro from Google who lost an eye with it.
Yes.
In a fight with AlphaGo.
Oh my god.
AlphaGo took my eye.
Arr.
I have a kitty beard.
Oh my god. This is ridiculous.
Oh.
This is enough.
Done. This is what I like. Watch. It gets bigger when I open my eyes bigger.
Oh.
What is it with the mustaches and beards?
They're fun.
Oh, I like this one. I feel like a San Francisco hipster now.
Oh yeah, definitely. Got enough wax in your handlebar?
That's right. I wax my handlebar. Aha.
Oh my goodness.
I can't.
I do have facial hair envy in some ways.
Oh, look, you look so cute now.
Oh,
where'd it go? I lost the cake and the tiara.
Oh my gosh, Scuba Puppy is very popular.
No, I get to be Dr. Kitty.
Oh, there we go.
To my Hangouts toolbox. There we go. That's my lower third. When did I do that?
Handlebar Kitty Princess.
Pamphlet.
Oh my goodness.
Pamphlet going back to the 90s for their health claims. Well, I mean, the 90s, it's not that long ago, but yeah. I would check up on those studies that they cite and see if they are actually good studies. Now you're the kitty Google tennis pro. Celebrating a win against Miauma Navratilova.
Oh my goodness.
Boosting, that's right, Arnlore. Boosting your immune system is not a good thing.
Why?
Because if you boost your immune system too much, it could start it. I can't talk to you. I can't talk to you. If you boost your immune system too much, then it might start it attacking your own body and start autoimmune disorders. Autoimmune disorders and allergies are symptoms of overactive immune systems.
Oh, I see.
Right? So immune systems that are so good. I mean, it's a colloquial term, I guess, the boosting the immune system. But I mean, you want your immune system to work appropriately, and you don't want it to be hindered by stress or poor diet or whatever you might, or lack of sleep, which I guess all basically is physiological stress. So stuff like vitamin C, being an antioxidant, can help. Your buddy at work had a boosted immune system once. He has no hair now. Right. Yeah, if you only ate oranges for a year, you definitely would not have scurvy, but you might have a lot of other problems. Yeah. Blair, you're so pretty in your tiara. All right.
Is it bedtime?
It's bedtime. I'm going to go do a whole show like this, just like this, just randomizing the Google effects.
Yeah.
That would be a really scientific show. We've been doing some really cool stuff. Yeah. Nobody mention it ever. Ever. No laughing. Right, Dave?
These are all going in my Instagram later.
Good. That's awesome. Yeah, I've clicked on the links and I have them open so that I can download. Downloading! It's a crack in my ceiling. That's where the wolves are going to come out.
Oh, how do I get rid of them? This is what I'm not sure about.
Arnlore, that's nicely explained. Your immune system is inflammation. Inflammation is prothrombotic. Thrombosis causes strokes and heart attacks.
I look too plain now.
You're like, I feel so naked. I feel like I'm missing my face.
Oh my goodness.
Oh, the tweets. Oh, the tweets. Snapchat dish pic. Awesome.
Oh my goodness.
Thank you. That's awesome.
All right. Yes, it's bedtime.
I love that.
Trey bedtime.
Post-show fun. Trey bedtime.
Trey.
Trey.
Boku bed.
Like,
Uber bed. Uber bedtime.
all right. I am going to go to sleep. I'm going to hang up now. We're going to go to sleep. Everybody have an internationally happy day on Sunday. Spread your joy germs. And we will be back next week at 8 p.m. Pacific time for more This Week in Science. Dave, 8 p.m. Pacific time. Dave. Good night, Blair. Thank you for the joy germs.
Of course. Thank you.
Good night, everybody. Thanks for taking all the screenshots. See if I can skip the screen caps. And we'll see you later. Later, skaters.